Before we can simulate with machine in Fusion 360, we need to import the correct machine. Tests have shown that the machine definition can alter the Gcode generated in unwanted ways, so it is recommended to use this machine definition provided with the BlackBox X32 4th axis post. First, download the latest post processes and the machine definition from GitHub. First thing to do is to download the latest version of the post processes from GitHub. Click the green button, select download zip. And this is the file you need to unzip. These are the files that are unzipped from the master zip file. After unzipping the downloaded file from GitHub, you need to import the machine into Fusion 360. Open Fusion 360. Create a new blank drawing. Select Manufacture from the main menu. Select Utilities from the top bar menu. Select Machine Library. Select the local folder. This makes the import icon available. Select it. Click the Select from My Computer button. Select the OB 4th axis router F3D file from where you unzipped the master file. Keep the name but select a destination within your Fusion folders. Click the Save button. Note that there is no model associated with this machine definition, so you will not see a machine during simulation. This machine does define the correct kinematics for a generic 4-axis gantry router with an A rotary axis with no rotation limits. So having imported the OpenBuilds 4-axis generic machine, we can select it as the machine. OpenBuilds 4-axis router. Make sure you're using the X32 4th axis post and post. I've got debugging turned on, so you won't see quite so much. But just as a sanity check, I know that my model is 40 millimeters diameter. Z0 is center of rotation, so the engraving should occur at just less than 20 millimeters, which is what we can see there. Now we can simulate with machine. It can't display a machine because there's no model in this thing, because there needs to be models for each of the lead and sphinx and so on. That's what we want to see. If that's the top. You can select the machine base. If you select model, then it will move the tool. If you select tool, then it will move the model. This is the 0 point for the model, which is the center of the face of the chuck. That's where you set XYZ 0 for your work coordinate system. And then all of your Z cuts are on the radius, which is easy to see. And Y should stay 0 for a radial cut. For these pockets, Y will change. And X will always be negative when in the cuts. You can see here that X is negative and Y is 0. And the rotary axis is rotating.